Hi, my name is Justin and I work at the Ventura College Tutoring Center, and today we're going to talk about applications of differentiation. Mainly finding the intervals of increase or decrease of a function, the local maximum and minimum values, and the intervals of concavity and the inflection points. So first we want to find the intervals of increasing and decreasing. So for that we need to look at the first derivative. So just differentiate f with respect to x. The derivative of 2x cubed is 6x squared minus the derivative of 3x squared is 6x minus 12. So now we need to set that equal to 0. But they have a common factor of 6, so we can factor that out. And we want this to be equal to 0. So we just need to set this equal to 0. Luckily it factors 2 and 1. Plus and minus. So that means that x is equal to -1 and x equals to +2. So these are our critical values. So we want to do a number line. We want to graph -1, our critical value, and our other critical value 2. And we want to look at numbers in between those. So we want to look at a number to the left of -1, so we can choose -2. And then we want to plug that into our first derivative and see whether or not it's positive or negative. So if we plug in -2 here, we would get -2 plus 1 is -1. And then -2 minus 2 is -4. So negative times a negative gives us a positive. So it's increasing here. And now we want to look at a number in between -1 and 2. So let's choose 0, the easiest one. So 0 plus 1 is 1, positive number. 0 minus 2 is negative. So positive times a negative gives us a negative. And now we want to choose numbers greater than 2. So 3. 3 plus 1 is 4, positive number. 3 minus 2 is 1, another positive number. Positive times positive is still positive. So that means we are increasing from -infinity to -1 and union 2 to infinity. We're not increasing at -1 or +2 because there the slope is 0. That's what we did when we set the derivative equal to 0. So at those points it's neither increasing nor decreasing. And then it's decreasing in between -1 and 2. So to find the local max and minimum, we look at our number line and where it goes from plus to minus. So where it's increasing to decreasing, we have a local maximum. So we have a local max at x equals -1. And then when it goes from minus to plus, or decreasing to increasing, we have a local minimum. And that occurs at x equals 2. So for the final part, we're looking at the intervals of concavity and the inflection points. So for that we need to take the second derivative. So we already took the first derivative, so now we just take another derivative of that. So we get f double prime of x is equal to 12x minus 6, and we want to set that equal to 0. We want to know where the second derivative is equal to 0. Where that occurs is our inflection points. So just factor out a 6, so we get 2x minus 1 equals 0. So we could just set 2x minus 1 equal to 0, 2x equals 1, x equals 1/2. So that's our inflection point. We only have one. So what we need to do now is make another number line and graph that number. And then we need to look at values to the left and to the right of that. So to the left, we can pick the number 0. That's always easiest to work with. Plug that into the second derivative. If we have a value of x being 0, we get 0 minus 6. That's negative. And then numbers greater than 1/2, let's try 1. We would get 12 minus 6, which is positive. So it's concave up. From 1/2 to infinity, not including 1/2 though, because at 1/2 it's neither concave up nor concave down. And our concave down is on the interval negative infinity to 1/2. So wrap things up, to find the intervals of increase or decrease, get your function, take the first derivative, set that equal to 0. The values that you get for that will be your critical values. That's where it goes from increasing or decreasing. Plug that into our number line. From there, we're going to tell whether it's increasing or decreasing. Where it goes from plus to minus, we have local max. Where it goes from minus to plus, we have a local min. Then after that, we want to find the intervals of concavity and the inflection points. So we take the second derivative, or the first derivative of our derivative, and solve for x again, set it equal to 0, solve for x. That's our inflection point. Graph that on a number line, look at values to the left and right of that. And where it's minus, it's concave down, and where it's plus, it's concave up.